Hey guys, welcome back to Battery Hacker. In this video, I am going to explain how batteries are connected in series and parallel for off-grid solar power systems. We will start with the basic ideas first, and then move step by step into more important points later in the video. Let's begin with series connection. When batteries are connected in series, the voltage increases, but the capacity stays the same. For example, if we take two batteries that are 12-volt and 100 amp-hour each and connect them in series, the result will be a 24-volt, 100 amp-hour battery bank. One very important rule here is, you should never connect batteries with different voltages or different capacities in series. This can damage the batteries and reduce performance. Now, let's talk about parallel connection. When batteries are connected in parallel, the voltage stays the same, but the capacity increases. Using the same two 12-volt, 100 amp-hour batteries, if we connect them in parallel, we will get a 12-volt, 200 amp-hour battery bank. You should never connect batteries with different voltages in parallel. However, batteries with different capacities can be connected in parallel, as long as they have the same battery chemistry. Now, why does series connection matter so much? When we increase the battery voltage, the current in the system becomes lower. Because of this, we can use thinner wires, which helps reduce wiring cost. A higher voltage system also allows us to use a smaller and cheaper charge controller. Let's look at a quick example. Assume you have a solar array of 700 watts, and you want to charge either a 12-volt battery or a 48-volt battery. With a 12-volt battery, you will need a charge controller rated at about 60 amps. But with a 48-volt battery, you only need a charge controller of around 15 amps. This clearly shows how increasing voltage can reduce system cost. Now let's focus on parallel connections and why increasing capacity can be very important. When we connect batteries in parallel, the total amp-hour capacity increases. This plays a big role in something called the C rate. I have explained C rate in detail in another video on this channel, but let's quickly summarize it here. When you increase the capacity of a battery bank, you reduce stress on each battery. This helps extend battery life and reduces heat. Let's look at a real example. Assume you have a lead-acid battery that is 12-volt and 100 amp-hour, and you are running a 1,000-watt inverter. For lead-acid batteries, the recommended C rate is 0.2 C. This means 100 amp-hours multiplied by 0.2 equals 20 amps. So ideally, this battery should be charged or discharged at 20 amps. However, to supply a 1,000-watt inverter, the system will draw about 83 amps from a 12-volt battery. This is much higher than the recommended 20 amps. Even though the system may still work, this high current will generate extra heat. Over time, this heat will reduce battery lifespan and also lower usable capacity. A better solution, especially if you already own a 12-volt inverter, is to increase battery capacity using parallel connections. Let's improve the system. If we connect 4 batteries in parallel, each battery being 12-volt and 100 amp-hour, the total capacity becomes 400 amp-hours. Now calculate the C rate again. 400 amp-hours multiplied by 0.2 equals 80 amps. This means the battery bank can safely deliver about 80 amps, which is very close to the 83 amps required by the inverter. This configuration is much healthier for the batteries and will give you better long-term performance. However, if you are planning the system from the beginning, the best option is usually to increase battery voltage, not just capacity. Now let's look at a system that uses both series and parallel connections together. Assume you have 4 lead-acid batteries, each rated at 12-volt and 100 amp-hour, and you are using a 1,000-watt 24-volt inverter. In this case, we can connect 2 batteries in series to make 24-volt, 100 amp-hour, and then connect the second pair the same way. After that, we connect both series strings in parallel. The final result is a 24-volt, 200 amp-hour battery bank. Now let's check if this system is properly sized. For lead-acid batteries, the C rate is still 0.2 C. So 200 amp-hours multiplied by 0.2 equals 40 amps. Next, calculate the maximum current drawn by the inverter. 1,000 watts divided by 24 volts equals about 41 amps. As you can see, the battery bank can safely supply almost the exact current that the inverter requires. This is a well-balanced system, and it will provide much better battery life compared to a poorly matched setup. There are several critical points you must always keep in mind. First, never mix batteries with different chemistries. For example, lead-acid and lithium batteries should never be connected together. Second, do not connect batteries that have a different state of charge. If one battery is full and the other is low, a strong current will flow between them, which is harmful. Always bring batteries to the same voltage first, and then connect them. Third, you should never connect batteries of different ages in series. Older batteries usually have less capacity, and they will limit the performance of the entire bank. When connecting batteries in parallel, make sure all connecting wires are the same length. If one wire is shorter, that battery will work harder than the others. A good solution is to use a bus bar, so every battery connects with equal length cables. Each battery in a parallel bank should have its own fuse. For lead-acid batteries, an ANL fuse is commonly used. For lithium batteries, you can use a circuit breaker, a Class D fuse, or a rail-mounted fuse, which is very popular in Europe. These devices have a high current breaking capacity, so if one battery fails, it will not dump current into the others. If your battery bank is exposed to vibration, make sure it is mounted securely. Keeping batteries cool will significantly increase their lifespan. Lead-acid batteries must be properly ventilated, even sealed types. Lithium batteries should never be charged below freezing temperatures, as this can permanently damage them. Also, some lithium batteries cannot be connected in series, so always confirm this with the manufacturer. When working with batteries, always wear safety equipment, remove jewelry, and use insulated tools. Right now, lithium iron phosphate rack batteries offer excellent value for their performance. I hope this video helped you understand how to correctly wire batteries in series and parallel for off-grid solar power systems. If you found this useful, please hit the like button, consider subscribing to Battery Hacker, and I will see you in the next video.